Swayam Prabha. Digital India. Educated India. Swayam Prabha. Digital India. Educated India.
Let us have a look at how we estimate the operating costs of an airline. The total operating cost of an airline is abbreviated as TOC, and the TOC has two major components, which are the direct operating cost DOC and the indirect operating cost IOC. DOC itself has three major subcomponents. The first is called as the ownership costs, which are related to the cost of owning the aircraft. Now, it need not be the property of the airline, it may be something which is leased by the airline. The next are the costs associated with the flight operations, and then we have costs associated with the maintenance of the aircraft. Going one step further, the ownership costs consists of depreciation, interest and insurance, and we are going to look at these terms in little bit more detail very soon. The flight costs generally consist of the expenses towards the cockpit crew, which is essentially the pilots, the cabin crew, which means those who are in the passenger cabin as crew members, the flight pursers and air hostesses. Then you have expenses towards the fuel, and also there are certain charges or fees that are paid by an airline to the airport and to the agency that provides air traffic management. So, we will club them together into the single name as fees. Under the maintenance costs, we have two major subcomponents: costs towards airframe maintenance and costs towards the engine maintenance, and each of these costs have again further subdivisions like material, labor, etc. So, we are going to focus mainly on the direct operating cost, because that is the cost about which we can talk with more confidence, that is on related to the technical side of the operation of the aircraft. The IOC is a function of the business side of the airline. So, we are going to focus more about the direct operating cost, and usually the IOC is very difficult to estimate. It may not be related with directly any of the operating or the maintenance expenses. So, therefore, our focus is going to be only on the direct operating cost. There have been several models proposed to estimate the DOC. The main reason for providing a model for DOC estimation is to have a level playing field when we want to compare the operations of various airlines or even the same airline on various routes. So, for that in literature there have been lots of DOC models which have been proposed. Basically, what is a DOC model? It is just a series of equations with certain design variables related to the aircraft and to its operation and to its maintenance versus the various cost terms. So, the first of these models worth mentioning was given way back in 1944 by ATA, and it was finally updated in 1967. So, we will call this as the ATA model. The next model appeared in 1989. It was given by the organization called AEA, Association of European Airlines. Then there was a model in 1995 called as the DOC plus I model, because it included certain additional terms over the ATA model. Then in 1999 we had a model called as DOC F41. I will talk about it in some more detail. And then in 2010 the Technical University of Berlin has given a model for estimation of the DOC of the civil transport aircraft. So, the previous models, the ATA stands for the Air Transport Association. So, all these models came either from the industry, the ATA and the AEA came from the airline industry, and DOC plus I and DOC F41 came from NASA. TUB model came from an academic institute. So, let us look at each of these models one by one and try to familiarize ourselves with its important and distinguishing features. The ATA method, as I mentioned, came from the Air Transportation Association. It was proposed in 1940 by Menzer and Norse of United Airlines. So, therefore, this model has come based on the data from the industry. To be very specific, at that time the most popular aircraft being operated by airlines was the DC-3, and based on the statistical data of DC-3, the formulae for the ATA model were derived, and these formulae were updated in 1967 to include turboprop and turbojet engines. Before that they were only meant for piston prop engines. So, that is why we say that the ATA model proposed in 1944 was further upgraded in 1967. This particular model, it needs aircraft and engine price as inputs. There is no method to directly estimate the effect of various engine parameters on the operating cost, primarily on the cost of the maintenance of the engines. So, it needs the aircraft price and the engine price directly as inputs. It includes several important terms which we discussed in the previous slide. For example, it includes depreciation, insurance, fuel, maintenance and cockpit crew, but it leaves out certain important terms such as interest, cabin crew, landing charges, navigation charges and passenger handling charges, or the fees that we had mentioned. Okay. So, in the ATA model, the crew costs are only concerned towards the cockpit crew, the cabin crew is left out. So, the AEA method, which came from the Association of European Airlines. So, therefore, it is obvious that this model uses data based on the experience of European airlines. So, in 1989, whatever was the cost situation, this model uses that data to create a methodology for estimation of the direct operating cost. You can call it as ATA because it contains all the terms that the ATA model has, but it includes landing, navigation and passenger handling charges which were missing in the ATA model. Also, rather than giving the engine cost directly as a number in the ATM model, in the AEA method of 1989, the engine cost is estimated as a function of some of the engine related parameters. So, therefore, you need to know the data regarding the engine. For example, you need to know what is the bypass ratio and the overall pressure ratio. You need to know how many compressor stages are there in the engine and how many shafts are there in the engine. These are some technical terms related to the engine. Okay. So, once you have the numbers for these parameters, then the model has got some formulae which can be then used to estimate the maintenance costs related to the engines. The DOC plus I method is a method which was proposed by Liebig et al. In 1995 and it was documented in a NASA CR. So, the cost of interest which was missing in the previous model has been included in this particular model, and this particular model was based on the economic data of the McDonnell Douglas aircraft, which was quite popular in the late 90s. Okay. So, this model was based on the subsonic aircraft design study carried out for NASA involving 4 aircraft and 3 engine types in those 4 aircraft, right, and equations were provided for each aircraft type. The next model which appeared was DOC plus F41, proposed 10 years later by Harris in 2005, again through a NASA contractor report. Here data related to the operational expenses of 67 airlines in 1999, they were collected. Okay. Interestingly, this was possible because the Department of Transport introduced a form called as Form 41, in which it asks the operators, the airlines, to provide information regarding certain parameters in each of the flights. So, this economic data in the Form 41 was collected and studied, and using this information some equations were fitted on the data to arrive at some estimates. So, the expense estimation equations for each element were arrived. So, let me give you an idea. This particular model is an outcome of data related to a total of 67 airlines, 46 of which were the passenger airlines and 21 of which were the cargo airlines or dedicated cargo airlines, and the number of entities was 118 total, plus these entities operated large number of aircraft. So, close to 6,000 aircraft data was utilized in creating the equations by, or I can say that data of nearly 6,000 airlines was fitted to arrive at the equations which are reported in the DOC plus F41 model. As per the NASA CR, it is mentioned that the total operating cost which was predicted using this model was approximately $89.898 billion for these 46 passenger airlines and $19.371 billion for these 21 cargo airlines. But when you match that with the actual data which was supplied by the airlines in the TOC Form 41, you find that the numbers are very near. As against $89.898 billion, the actual number from the Form 41 was $90.057 and so forth. So, there was an error of only about $1 billion, okay, $1.3 billion approximately error over $109.2 billion. So, therefore, the percentage error in the predicted values against the actual quoted values was approximately 1.2% in all. So, it is a very small deviation from the actual data. So, this was a very popular model. Then as I mentioned, in 2010, Professor Thorbecke of the Technical University Berlin, he proposed a model which can be used for civil transport aircraft, and the equations of this have been made public. This particular model was updated by Scholz 3 years later in 2013, and a central reference aircraft data system has been created called as CIRAS, and in this CIRAS all these information has been placed. So, what is CIRAS? It is the central database which hosts the design data of commercial aircraft, and in this particular TUB model, the cost of the engine is estimated as a function of the weight of the airframe and weight of the dry engine supplied by the engine manufacturer to the airline, and the utilization of the aircraft annually is a function of the block time, the downtime and the night curfews which are prevalent at some places. So, the formulae for this particular method are available freely on the CIRAS website, which is mentioned there. Anyone who is interested to know about the method and about the formulae used in this method is welcome to refer to this particular website and use it for your calculations. Let us look at a simple method for estimating the direct operating cost. This model was developed by us somewhere in 1996, essentially for modeling the costs related with the operation of regional and commuter airlines. However, the model is generic in nature and one can always implement this model as it is, or you can adopt it to meet your requirements. So, in this model the DOC is estimated as a function of 7 individual components. The first of these is called as the standing charges, abbreviated as C stand. Then we have the crew cost, abbreviated as C crew. Then we have the fuel cost, abbreviated as C fuel. The maintenance cost, abbreviated as C maint. The landing charges payable for providing the landing service of an aircraft paid to the airport. The navigation charges payable to the agency that provides the air traffic management services, and the handling charges which are charged by airports to provide facilities to the passengers, and the security and other parameters. So, these 7 components added together represent the direct operating cost of a typical airliner. Let us look at how we estimate the block time and the annual utilization. Block time is generally a term measured in hours, which stands for the total time that transpires between the time that the aircraft is released from one particular airport till the time it arrives at the other airport and it is finally stopped and no further motion is permitted. So, this is from the chocks off to chocks on. Chocks basically are triangular yellow colored devices which are inserted in front of the wheel when you do not want the aircraft to move inadvertently. So, the time between chocks off to chocks on, or the block time, it will be a summation of 2 times. One is the T stage, or the time needed for the taxi out, take off, climb, cruise, descend, maybe land, taxi in and stop, that is called as the stage time, the time needed to travel from A to B. And then between the arrival at an airport, and before it can be again departed to the next destination, there is a small time which is called as a turnaround time, also called as TAT. So, this turnaround time and stage time together adds up to what is called as a block time, and we are going to look at turnaround time and how it is reduced little bit in the next few slides. So, as I said, T stage is a total flight time, and turnaround time depends on the aircraft type. It could be depends on the aircraft type. The typical value for commuter and regional aircraft operating on very short routes which do not necessarily require refueling between two hops, and when a less number of passengers, 15, 19, 30, 40 passengers to deplane with their baggage, that can do probably within about 15 minutes of time. But when we have short haul jets, the turnaround time, for example, if you look at a typical aircraft like Airbus A320 or Boeing 737, the time between one arrival and the next departure could be of the order of around 30 minutes. But when we look at long haul jets such as Airbus A300, A310 or Boeing 747, these are large aircraft. So, there we require a turnaround time of 90 minutes. Many a times the turnaround time is also a function of how much time is needed by the brakes to cool down after a very harsh and heavy landing where the brakes have been deployed. So, sometimes it has been seen that these brakes become red hot and there is no way to cool them immediately except just waiting for it to have normal cooling with the ambient conditions. So, therefore, you may have to wait for the brakes to reach a reasonably low temperature for them to be operational again. So, there are many reasons which affect turnaround time, and we will look at the turnaround time for short haul jets and see how it can be reduced and what attempts are made by airlines. Some very interesting attempts are made by airlines to reduce the turnaround time. As far as the annual utilization is concerned, well, aircraft make money when they fly, when they remain in the air. So, the more the time for which an aircraft is flying and remaining in the air productively with passengers, higher is the benefit to the airline. So, all airlines try to increase the annual utilization of an aircraft to the extent possible. There are some upper limits. So, the number of hours flown per year, which is a function of the number of routes which are flown and the frequency of flights, these parameters directly affect the annual utilization in hours. Now, for long range aircraft, you have a higher utilization because they remain in air for a much longer time in proportion to the total time. Short haul aircraft, they have lesser utilization, although they do more hops, but between every hop there is a certain turnaround time which can actually reduce the utilization. So, the typical values of maximum annual utilization are as follows. For a long range aircraft, you could have as high as 3750 hours per year, and for a short range aircraft, because of the multiple hops and the requirement for some turnaround time between each of them, the total number of utilization would be max around 3600. What are the tasks which are done during turnaround? Let us take an example of a typical medium range jet aircraft. So, here is a picture showing the various vehicles and systems that come and dock themselves to an aircraft. So, what is the sequence? The first thing that you do when an aircraft arrives at an airport is chocks on, that means you make it to stop any further motion, and then the crew and the passengers have to disembark from the aircraft. For that, you can use a combination of many schemes. Some airlines, they use a stairway, and then there are buses which take you to the terminal building. in modern times we see the passenger loading bridges which are being used to directly allow people to go to the terminal building without the need for ground transportation. After that or parallelly, actually these activities happen parallelly, they do not happen sequentially, because then it will be too much turnaround time. So, there are a group of people who are cleaning the cabin and the toilets after the passengers have disembarked. So, there is a water service truck as shown here and there is a lavatory service truck as shown here. Then parallelly the baggage of the passengers is being unloaded as well as the cargo. So, for that the bulk loaders or high lifters are used by airlines to take out the baggage. Then aircraft is inspected as per a standard operating procedure. This is the maintenance requirement. There is always some minor maintenance done between two flights and there is a set sequence of operations, investigation and observation of the control surfaces, observation of the engine and the nacelle to see that there is no obvious and clear cut damage to the blades or to the cowling. Then we look at nitrogen bottles, we look at the landing gear, we inspect these things visually. So, you will see some engineers going around the aircraft with a torch, and sometimes even the pilots are qualified and trained to do this kind of observation of the aircraft between two flights. Then you do refueling of the aircraft. So, you load the food and beverages using the galley service trucks. Generally we use both the front starboard or the right door and the rear starboard and the right door, because generally there are two galleys, one in the front, one in the back, especially in the medium range airliners. And then parallelly the cargo and the baggage of the next flight is being loaded and passengers are also embarking on the aircraft along with the crew members. So, all these activities happen in parallel and it requires some finite amount of time. Now, by using certain facilities and equipments on board the aircraft such as the auxiliary power unit, then it is possible for us to utilize the APU to remove the requirement for an electrical ground power unit or a air conditioning or air starting vehicle. Okay. So, let us look at the turnaround time breakdown of a typical airliner. Okay. So, these numbers are realistic, but they do not represent to any specific aircraft. All I can say is that these are numbers which are more applicable for a medium range airliner in which the turnaround time is of the order of half an hour. So, in this case it is about 26 minutes. So, you notice that many things are happening in parallel, and also you notice that some of the things have a requirement for position and equipment and then the activity takes place, and there are some activities which require a support equipment to be positioned. You do the activity and then you have to move it away, such as the fueling. The numbers here are approximate time in minutes that is required for carrying out these individual activities. We notice that the largest time is consumed by unloading the mid compartment or taking the passengers, deboarding the passengers, and also boarding of the passengers and servicing of the cabin, plus fueling of the airplane. So, therefore, these activities which are approximately 9-10 minutes each are happening parallelly. Okay. So, let us have a quick look. So, there are three kinds of activities. There is passenger servicing, there is cabin baggage handling, both offloading and onloading, and then there are airplane servicing activities. Okay. So, servicing the lavatories and servicing of the portable water requires about 2 minutes each. So, for that you have to bring some vehicle, do the activity and then take the vehicle away. Similarly, this is for the lavatories, you bring a vehicle, do the activity and take it away. Fueling of the airplane also requires the same thing, and it takes perhaps the maximum number of time amongst the airplane servicing. Cargo baggage handling is the one that consumes the maximum time. You can see that the ones in the yellow color are the critical paths, which are the normal reasons for increasing turnaround time or delay in turnaround. So, here we notice that loading the aft compartment and unloading the mid compartment are two major activities. All other activities are relatively much lesser time intensive. And then you have passenger services, where servicing the cabin and boarding the passengers approximately 10 minutes each are the two things that take the maximum time. So, by doing the activities in parallel and by doing them efficiently, one can reduce the turnaround time and therefore increase the utilization, which makes it more profitable and more efficient operations for the airline. Many attempts have been made to reduce the turnaround time by using innovative and novel techniques. We will look at one of them. The largest component of turnaround time, as we have seen, is deboarding and boarding of passengers, correct. And there are some strategies to reduce the turnaround time. One simple strategy is the use of the aero bridges or the passenger boarding bridges, as I mentioned. As the aircraft comes to the terminal, you can just connect a passageway or a gate, aero bridge, and people can just from the front quickly deboard, and once they finish deboarding, the other passengers who are flying can start boarding. Okay. So, here is an example of these aero bridges which are connected to the terminal. There could be just one aero bridge, or there could be two independent aero bridges, one for the business class and the first class passengers and one for the economy class passengers. Okay. These are very useful when you have very large aircraft. Then another strategy is that you do not give any seat number to the passengers, you just ask them to board on first come first serve basis. So, the moment people queue up and they go inside the aircraft, they just choose the place that is available to them and just sit there. So, there is no issue regarding what is the seat number, is it an aisle seat, is it a window seat, is it a middle seat, all those problems are minimized by allowing free seating. Then many airlines use strategies so that the time required to clean the cabin is reduced. It has been found that if you do not give any seat back pocket, then there is less time needed by the crew members to clean the aircraft between two departures. Then one can use both the front and the rear doors for deboarding and boarding in the aircraft, that will save time. And studies have shown that you can reduce the time by about 50%. Then you can also have boarding segmentation strategies. Okay. For example, you can say that first we will fill the rear seats, then we will fit the middle seats, and then we will fit the front seats. Okay. Except that in the front you also have the executive class and the first class. So, they normally have their own aero bridge. Okay. But if they do not, you can allow the executive class to sit first, or the passengers who have certain privileges to sit first, and then what you can do is you can zone the aircraft into zone 1, zone 2, zone 3, etc. and you first fill the people in the back so that there is no disturbance to the other passengers. Once the rear seats are filled up, you can say the middle seats are now open to be filled up, and then the front seats. The other option could be that you first fill the front seats, then the middle seats, then the rear seats. This is very useful in small aircraft when the boarding takes place from the door mounted on the back side of the aircraft. So, here is the reverse, because you are going from the rear door, you go straight in the front and then in the middle and then on the rear. Or you could say that first we will allow all the people who are having window seats to move in and get seated in the windows. Then we allow all the people who have the middle seat to go, and then we allow finally the people who are on the aisle seats. This can be a potential problem because many people travel together and they would like to board the aircraft together. And if you say that window seat first, then the middle seat, then the aisle seat, they may get disturbed. The families or groups traveling together may get separated, they may not like it. But these are attempts which have been made, which have been used by airlines to reduce turnaround time. A very interesting strategy was for the first time implemented by an airline in India called Indigo, in which they used 3 doors for embarkment. Okay. So, on their 16th anniversary on 4th August 2022, they implemented this scheme that they would use both the front doors and also one of the rear doors for disembarkation and embarkation of passengers. So, the current turnaround time of A321 in Indigo was about 13 to 14 minutes, and by using this particular strategy they claim that they can reduce it further by nearly half to about 7 to 8 minutes. Okay. Now, these strategies were attempted at 3 major airports, Bengaluru, Mumbai and Delhi, and once they are tried out and tested, they will be slowly implemented at all other stations. Interestingly, this is the first time in the world that any airline has used a strategy of using 3 doors for deboarding and boarding of the passengers, and you can see that the turnaround time has come down drastically, allowing the aircraft to be in the air for more time. Okay, moving on, there are some standing charges, as I mentioned, which are related to the ownership of the aircraft, and as I said, ownership does not necessarily mean that the aircraft are owned by the airline, they could be leased by the airlines. Okay. So, standing charges are charges which are incurred by an airline even if the aircraft is just standing and they are not operating the aircraft. These are to do with the ownership of the aircraft. The standing charges consist of 3 basic terms: the depreciation of the aircraft, which is essentially the loss in the value of the aircraft because of the passage of time. See, you buy anything and the moment you buy it, it becomes old, and if it is now to be sold, it is second hand. So, the price drops immediately. This happens with anything. You buy a house and within a month, if you go to the market to sell the house, the price may actually drop drastically. You buy a new car and after 1 month of operation, it will depreciate to a very low value because now it is not new. Similarly, with the passage of time, any asset loses the value, which is called as depreciation, and in aircraft operations, we either assume a certain percentage of the value of the aircraft, let us say 90%, which depreciates over maybe 15 years or whatever time. Okay. Sometimes we assume that the value at the end of the life is 0 and there is going to be a linear depreciation over say 14 years or 15 years. Then we have to cater for insurance. Insurance is the premium that you pay for insuring the hull, that is the aircraft and the structure, engines, the crew and the passengers who are flying in the aircraft. So, should there be any untoward incidents and because of that some passengers are injured or lose their lives, and same for the crew members, then the premium that you pay for the insurance takes care of the statutory requirements for insurance for the passengers or the crew members, and also if there is a damage to the aircraft or the engine or both because of an incident or accident, then that is also covered by the insurance. And then aircrafts are very expensive. So, therefore, most airlines do not put their own hard earned money onto procurement of aircraft. They actually take a loan from a financial institution to buy aircraft and then they have to pay the interest. So, the financial payments which are made for either procurement of the aircraft, or if you do not want to buy, you want to lease, you have to make some payment towards the lease charges. So, these are coming under interest. So, in general, the standing charges would consist of these 3 terms: depreciation, interest and insurance, and this particular amount has to be incurred even though the aircraft is not flying. That is why they are called as standing charges. They are incurred even if the aircraft is just standing. Then a very important part of the variable costs in direct operating costs are the flight crew and the maintenance costs. Okay. So, let us look at it one by one. There are two kinds of crew members. Those who are flying the aircraft in the cockpit, we call them as cockpit crew. So, generally we have in medium range transport aircraft a crew of 2 members minimum for an 8-hour period or thereabouts. If the flight duration is more than 8 hours, you are generally required by regulatory authorities to have a separate set of crew members who would be resting otherwise and then taking over after the 8-hour period is over. So, what are the expenses? There are some annual salaries to be paid to the crew members, and then for every flight that they incur there are some allowances, okay. Plus there are expenses related to their accommodation and transport. Then you have cabin crew members who are the ones that serve the passengers in the cabin and are meant for ensuring safety during the operation in the cabin and especially during emergencies. So, these are the flight pursuers and the air hostesses. The general industry norm is that you need to have one person in the cabin crew for about 35 passengers or 50 passengers, depending on whether you are operating a proper whether you are operating a proper service, depending on whether you are operating a commuter service or a mid-range service. So, when you are operating a commuter service or a very low cost operation, 35 passengers. When you are operating a commuter service or a regional airline service or a low cost operations, you can have one crew member in the cabin for 50 passengers, but generally to provide a decent level of service, the mid-range aircraft, they generally have one cabin crew member per 35 passengers. So, if there are 100 seats in the cabin, there will be minimum 3 members in the cabin. So, what we do normally to take care of the cabin crew cost is that we slap it as an additional percentage to the cockpit crew cost. In some formulations, specific numbers are given for the cost of cabin crew per flight hour. In some we just say that you add additional 20% or 30% to take care of the cost of the cabin crew. As far as maintenance is concerned, as I said, there are two major components, the airframe maintenance and the engine maintenance. In the airframe maintenance, you measure these costs either in so many units of currency or dollars per flight hour or per trip or per annum. There are various kinds of numbers which can be calculated. There are two major components here. There is a material cost and then there is a labor cost. The material cost represents the cost of changing materials which have to be done. The material cost represents the cost which is spent towards the material that is used for the maintenance. For example, after a certain number of landings, you need to change the tires. So, therefore, there will be some material cost and there will be also a cost towards the labor to actually do this particular task. As regards as engine is concerned, again you measure the cost or you estimate the cost in terms of per flight hour or per trip or per annum. Here again you have the cost towards material and labor. For example, there are certain O-rings to be changed after a particular frequency or some other small equipment related to the engine which has to be changed after so many hours of operation. So, you need the cost towards procuring those items and also you need cost for the labor for doing it. But in the case of engines, there are certain things which are not touched or changed or modified by the maintenance engineers of the airline. They are not authorized to do those things. So, the engine has to be taken off and sent to the original equipment manufacturer for what is called as an overhaul. So, there will be some overhaul cost per annum also in addition to the engine maintenance. There is a similar cost also for the airframe, because after so many flying hours you do check B, check C, check D, etc., for which the aircraft has to be many a times it has to be sent to the maintenance organization, or there are also some organizations which are certified or qualified to do it in-house in their own maintenance hangars. Let us look at the principal variable cost in the operation of an aircraft, which is the fuel cost, cost towards fuel and oil. So, here let us have a look at what kind of fuel is used by various aircraft types. There is a jet fuel which is called as jet A1, or it is basically kerosene. This is used for gas turbine driven engines, turbojet and turboprops, both they use jet A1 fuel. Then you have avgas or aviation gasoline. This is used by piston prop engines and it is nothing but leaded gasoline with a 100 octane rating. Then you can also have something called as jet B or kerosene gasoline mixture. These are used for military jet engines. So, they are actually not normally available with airlines unless they are also doing the maintenance for the transport aircraft of the military. And then you have biokerosene, which is kerosene biofuel mixture. These are used for gas turbine aircraft, both civil and military, and this is the direction in which the industry is slowly evolving. Okay. Now, interestingly, it will be a nice idea to get a feel about what does it cost for a jet fuel in India. So, here are some numbers which are available from the website of one of the oil and fuel providers in the country for aviation, called as the Indian Oil Corporation. So, as on their website, applicable from 1st August 2023, the cost in the metros for domestic airlines is as follows in the 4 metros in India. So, it is like 98,508 rupees for 1 kiloliter or 1000 liters. So, you could say okay 98.5 rupees per liter in Delhi. Kolkata is the most expensive, 107 rupees per liter. Mumbai has 92,124 or 92 rupees per liter, which is the cheapest in the country among the 4 metros for ATF or aeroturbine fuel, and Chennai has 102.391 per liter. When we look at the ATF prices in metros for domestic airlines on international run, okay, and assuming a particular currency rate, the numbers are much lower, okay, something like 74 to 77 rupees per liter. So, the fuel that is used by an airline is approximately the same or similar cost as the fuel used by our cars and two-wheelers for operating on the roads, provided you are on domestic routes. On the international routes, there are different rates and they are lower than those for the domestic operations. Finally, we will look at the charges which an airline has to pay for operation at the airports, for landing at the airports and for the navigation in the air, which was clubbed under the term fees in my first slide. So, the first component is the route navigation facility charges or the RNFC. This is a function of how much distance an aircraft travels in the flight information region or in the airspace which is controlled by a particular country as allocated by ICAO. The whole world has been divided into several FIRs and each member of ICAO has been given the right to provide services over various FIRs. So, when you travel on a particular FIR, depending on how much distance you travel, that is the distance in which you have to get the navigational support. So, it is charged per nautical mile travelled in the FIR, and also it is a function of the size of the aircraft. Okay. Heavier aircraft are charged more compared to lighter aircraft. We have the terminal navigation landing charges, abbreviated as TNLC. These are also a function of the size of the aircraft, and these are to be paid for allowing the aircraft to land. Sometimes they are called as landing charges, okay, but also to provide the communication, navigation, surveillance and air traffic management services to an aircraft as it comes into land. So, this is a function only of the size of the aircraft. Here we do not look at the kilometers travelled. So, RNFC charges are payable even when you are just flying over a country. Depending on how much time you spend in the FIR operated by a country and the size of the aircraft, you have to pay charges to that particular country to provide you the route navigation guidance. And when you come into land, then depending on the size of the aircraft or weight of the aircraft, you have to pay landing charges. The next charge is the passenger handling charges, which are generally either the user development fee or the passenger security fee. The user development fee is something akin to what you pay as a toll tax when you use a privately operated or maintained road. Okay. So, similarly, when an airport was developed, there was an expenditure incurred by an agency and they would like to recover that expenditure from the passengers who are travelling, that is the user development fee, plus the fees, the expenses that an airline, plus the expenses that an airport incurs in maintaining the escalators, the lifts, the staircases, etc. Plus there is also a passenger security fee, which as you can make out is towards the provision of security services to the passengers. Now, these charges are a function of the maximum capacity of the aircraft. Whether the aircraft goes full or half empty, there is generally a fixed passenger handling charges based on the number of passengers that would have been travelling in that aircraft. So, that is all. These are the various charges which constitute components of the direct operating cost, and once you look at the formulae or the procedures for each of these terms, you will then be able to estimate the DOC for a particular airline either on a particular route or on various routes. Thank you so much. Thanks for your attention.